function f of x using the formula integral minus infinity to plus infinity f of u e to the power minus I lambda u du. The Fourier transform of a function small f of x is denoted by capital F of lambda. Okay. Now this is two-way definition. I mean to say, if you give me a function f of x, I can always find out Fourier transform of that function, capital F of lambda. And if you give me capital F of lambda, I should be able to find out the original function f of x whose Fourier transform is this. So inverse, the process is called inverse Fourier transform. So inverse Fourier transform of f of lambda is given by 1 upon 2 pi integral minus infinity to plus infinity capital F of lambda e to the power I lambda x d lambda. So a function Fourier transform given by this formula. If you have a Fourier transform, then the original function will be given by this. Okay. So my question is, if sorry, how to represent f of x as an integral of some other function. Anyone? So this same thing is called Fourier integral representation of a function f of x. So I want to express f of x as an integration of something. How can you do that? No one. Okay. So if I want to express the function f of x as integration of some other function, so what we do is we find out the Fourier transform of it. I will get this. Okay. And then I can place this f of lambda here, so that what I will get f of x is equal to integration of this function. So I have expressed or represented f of x as integration of f of lambda. So this representation, I mean just placing it in the integral, is called Fourier integral representation. Now, if f of minus x is equal to f of x, then f of x is called, fill in the blanks, if f of minus x is equal to minus of f of x, then f of x is called dash. Anyone? So this is even function. So if f of minus x is equal to f of x, then it is even function. If f of minus x is equal to minus of f of x, then f of x is odd function. So if f of x is even, then I can simply jump to Fourier cosine transform. So cosine transform is denoted by f suffix c of lambda, Fourier cosine transform, and the formula is integral 0 to infinity f of u cos lambda u du. And the inverse Fourier cosine transform f of x is given by 2 by pi integral 0 to infinity fc of lambda cos lambda x d lambda. So Fourier cosine transform is this. Look at this three formulas you will have to remember. The first one is Fourier transform, inverse Fourier transform. Now Fourier cosine transform, inverse Fourier cosine transform. And the third one is sine transform, Fourier sine transform. Fs of lambda is equal to integral 0 to infinity f of u sine lambda u du. An inverse Fourier sine transform will be given by f of x is equal to 2 by pi integral 0 to infinity fs of lambda sine lambda x d lambda. So based on these three formulas, the a whole chapter is covered. Okay, you won't require anything else out of this. You must be able to check whether a function is even or odd. So that's why these definitions are important. If f of minus x is equal to f of x, like say f of x is equal to x square, I will write it down here. So f of minus x will be equal to minus x square, which is simply equal to x square is equal to f of x. So क्या मिला? F of minus x is equal to f of x, and that's why the function is even. Once the function is even, I can directly find out Fourier cosine transform. If the function is odd, I can find out sine transform. Okay, so that's all about the all the theory part about Fourier transforms.
Sir, just
Hmm.
a second. Can you show that page again?
Which page?
The previous one, the formula one.
Hmm. I will summarize this all. Wait, yes, I'm going to summarize this all on one sheet. Then you take the screenshot of it. So
Okay, sir.
transform. First of all, I'll write down the Fourier transform. Then I will write down the formula for inverse. Okay. So Fourier transform of a function f of x is denoted by capital F of lambda, and the formula is minus infinity to plus infinity f of u e to the power minus I lambda u du. And the inverse Fourier transform is given by 1 upon 2 pi integral minus infinity to plus infinity capital F of lambda e to the power I lambda x d lambda. So when you solve this, you will get f of x. Now we will have cosine transform. For cosine transform, the cosine transform is denoted by f suffix c of lambda integral 0 to infinity f of u cos lambda u du. An inverse Fourier cosine transform is given by 2 by pi integral 0 to infinity f of u f sorry not f of u capital F suffix c of lambda cos lambda x d lambda. And the third one is sine transform. Now Fourier sine transform is denoted by f suffix s of lambda, which is equal to integral 0 to infinity f of u sine lambda u du. An inverse Fourier sine transform is given by 2 by pi integral 0 to infinity f suffix s of lambda sine lambda x d lambda. So now you can take the screenshot of it. Just one reminder, if you want to, if the question is uh, give the Fourier integral representation of a function f of x. So what do we mean by Fourier integral representation? You just need to take the Fourier transform of it और उसको बस inverse के formula में रखना है. Okay, so I will find out f of lambda. Where is f of lambda? Yes, so this is f of lambda and I will place it in this formula. ये फॉर्मूले को सॉल्व नहीं करना है, जस्ट यहाँ पे रख देना है. ये रख, this is called Fourier integral representation. Fine. Now we'll go to examples. Before we go to examples, we will just write down some important formulas. So prerequisites. First one, integration of uv dx, where u is polynomial. What is the important thing about the polynomials? What happens to the derivatives of polynomial? Anyway, so u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 so on. So this is called generalized UV rule. So why do we call it generalized UV rule? So u is a polynomial, it means that it is of the form say x raised to 4. Integration of x raised to 4 into e to the power 2x dx. If I want to solve this, look, you will have to apply Eilert rule over here, and that too 4 times. So what this formula will do is it will give you the answer in just one step for this integral. So it says that you keep u as it is first, x raised to 4. जो suffix है v1 means one time integration of e to the power 2x, that is e to the power 2x by 2 minus Take the derivative of this term over here, which is 4x cube. Then integration of this, because यहाँ पे क्या है 2 times integration of v. ये हो गया first time. The second time will be e to the power 2x by 4 plus take a derivative of this, that will be 12x square. Again an integration of this, e to the power 2x by 8. I'll go ahead minus 12x square का derivative, which is 24x, into one more integration of this, it will be e to the power 2x upon 8 into 2 16, plus one more derivative of this, which will be 24, and integration of this, e to the power 2x by 32. So you can see that just in one step I have done 4 times UV rule, and you can see that if I go ahead, derivative of 24 will become 0. So this formula is only applicable when you have one of the term is a polynomial. Now to memorize this generalized UV rule, since it is very much important and big integration will be converted to very small integrations just by use of this generalized UV rule. So we just have to write it down there that suffix represent the number of integrations, suffix represent number of integrals. Second, integration e to the power ax cos of bx dx. Does anyone know this? No. So the formula is e to the power ax upon a square plus b square in bracket a cos bx plus b sine bx. And there are these some new students, Simid, Nimish. I just want to tell you that this is a new chapter. Okay, so you won't have any problem. Just the problem is about the first chapter, which we have already completed. So for that, I will give you the YouTube link. The lectures are there already. So when I conducted it, I have posted it on the YouTube, so you can watch it from there. Okay, and
Sir, you didn't have shared the YouTube channel yet.
I have shared it, Raj.
So can you share again on the group? So
Okay, यश
Yes, sir.
शेयर हुआ है ना ग्रुप पे?
हाँ, sir.
हाँ ठीक है, ठीक है, I'll
okay, sir,
share it.
can you please re-forward it? So
हाँ,
it gone very long time ago.
okay. Okay, so I'll come back to our chapter, new chapter, third one. Integral e to the power ax sine bx dx is equal to e to the power ax upon a square plus b square. The formula for this is a sine bx minus b cos bx. Just depending on this, the fourth one, integration 0 to infinity e to the power minus ax cos bx dx is equal to. I'll give you 2 minutes. I want someone to use this second one and find this fourth one. Can you use the second formula and find the answer of the 0 to infinity e to the power minus ax upon e to the power minus ax cos of bx? Take 2 minutes and try to find it.
Sir, e to the power ax upon a square minus b square.
Yes, I can't hear you.
Can you repeat it?
E to the power ax a square divided by a square minus b square.
Can you can you simplify it? Simplify it and tell me the final answer. Okay, anyway, take it as a homework. I'll write down the answer. The answer is a upon e square plus b square. And fifth one, 0 to infinity e to the power minus ax sine of bx is equal to b upon a square plus b square. Remember this. Again, this fourth and fifth formula will be useful a lot of times. Example. Find the Fourier transform and also give the Fourier integral representation of f of x is equal to 1, 0 less than or equal to x is less than 1, and it is equal to 0 for x greater than 1, comma x less than 0. So Fourier transform of this will be given by f of lambda is equal to integral minus infinity to plus infinity f of u e to the power minus I lambda u du. But even if the limits are from minus infinity to plus infinity, our function is not from minus infinity to plus infinity. Our function is from 0 to 1. I mean, otherwise it is 0. Okay, so I will take the values where it is non-zero. 0 to 1, 1 into e to the power minus I lambda u du. What will be the integral? Integration of e to the power minus I lambda u is e to the power minus I lambda u minus I lambda being constant will come in the denominator. Limits from 0 to 1. So if you put the upper limit e to the power minus I lambda upon minus I lambda minus, then you put the lower limit e to the power 0, it will become 1. This will make minus minus will become plus I lambda. So what do we have? F of lambda is equal to 1 minus e to the power minus I lambda divided by I lambda. Now the Fourier integral representation is, what do we have to do?
Inverse.
Inverse. So f of x is equal to 1 upon 2 pi integral minus infinity to plus infinity 1 minus e to the power minus I lambda upon I lambda bracket complete e to the power I lambda x d lambda. Final answer, or we should solve it? Shaunak,
Yes, sir.
should we solve it further?
Sir, I think yes, as it is the first example.
As it is the first example.
हॅलो सर, आदित्य
हाँ,
जावळकरला ऍड करा ना. त्याचं
आदित्य
कनेक्शन
जावळकर.
एरर झालेलं.
हा,
त्याचा नेटवर्क इश्यू होता म्हणून तो बाहेर पडलेला.
अच्छा.
हम्म.
त्याचे रिक्वेस्ट आल्यावरती आपोआप एक्सेप्ट होईल. रिक्वेस्टच नाही आहे ते. बरं हे सांग ना, करू का इंटिग्रेशन सॉल्व करू?
They have only asked to represent.
No, wait, let Abhishek answer. Abhishek, okay, let's go ahead. So it is just a representation, so I just have to put f of lambda. Okay, जहाँ पे भी representation आएगा, you just place it, you don't solve it. Okay, so that is our final answer. So go ahead. Next example. Find Fourier integral representation of f of x is equal to 1 for mod x less than or equal to 1. and it is equal to 0 for mod x greater than 1. And hence evaluate. And hence evaluate integral 0 to infinity sine lambda cos lambda x divided by lambda d lambda, and integration 0 to infinity sine lambda by lambda. Okay, so we'll just first of all observe the function. The function is an even function. Okay, so f of x is an even function, that is f of minus x is also equal to f of x, and that's why it is turning out to be even. Once the function is even, I can go for Fourier cosine transform fc of lambda. The formula for fc of lambda is integral 0 to infinity f of u cos of lambda u du. Our f of u is not from 0 to infinity, it is just from 0 to 1. So that's why integral 0 to 1 f of u is 1 cos lambda u du. If you take the integral of cos lambda u, it is sine lambda u upon lambda, limits from 0 to 1. So if you put lower limit, it is 0. For upper limit, it is sine lambda by lambda. So the Fourier integral representation is Fourier integral representation is f of x is equal to 2 by pi integral 0 to infinity sine lambda by lambda cos lambda x d lambda. Okay, so this is the formula for Fourier inverse Fourier cosine transform. Okay, and we want to find out the value of integral only. So from this, what do we get? Integral 0 to infinity sine lambda cos lambda x divided by lambda d lambda is equal to pi by 2 into f of x. Now my question is, if I want to get the second expression from the first one, what is the value of x that you should put?
One.
X, I ask, cos lambda x will be 1, then you will get the other expression. But what is the value of x? Cos lambda x becomes 1, then you will get sine lambda by lambda. So my question is, cos lambda x 1 कब होगा? For what value of x will cos lambda become
0.
1? 0. So put x is equal to 0. So in this, put x is equal to 0, then what do we get? Integral 0 to infinity sine lambda by lambda d lambda is equal to pi by 2 f of 0. But if you look at this part, f of x is equal to 1 for mod x less than 1. So f of 0 becomes 1. So the answer is pi by. I hope the idea is clear to you. Fine. Next example. By considering Fourier Sine transform of f of x is equal to e to the power minus mx with m greater than 0, prove that integral 0 to infinity lambda sine lambda x divided by lambda square plus m square d lambda is equal to pi by 2 e to the power minus mx. So just take the Fourier sine transform of f of x. So Fourier sine transform is, so f s of lambda is equal to integral 0 to infinity e to the power minus m u sine lambda u du. Can anyone tell me what is the answer? Anyone?
e, e to the power minus mu upon y.
Tell me the final answer. The two formulas those I gave you, from that the answer for this is lambda upon lambda square plus m square by inverse Fourier sine transform. What do we have? F of x is equal to 2 by pi integral 0 to infinity f s of lambda sine lambda x d lambda. Let's put the values, taking pi by 2 on the other side, pi by 2 e to the power minus mx. The right hand side is integral 0 to infinity fs of lambda is lambda upon lambda square plus m square sine lambda x d lambda. So we have shown this was to be shown. Okay. So I will give you a homework over here. By considering Fourier cosine transform of f of x, show that by cosine transform, show that integral zero to infinity cos lambda x by lambda square plus m square d lambda is equal to pi by 2m. Do this. In tomorrow's lecture, we will end the Fourier transform, and from Monday, we can start Laplace transform. That's all for today. We'll download the attendance list. Okay, thank you, everyone.
Thank you, sir.
भाई अटेंडेंस का क्या इशू है?
जावळकर